Today we are talking about groundwater and how water gets to be groundwater. So let's go ahead and show you some images. All right, so groundwater and infiltration is what we're talking about. So by the end of the lesson, so this lecture and the lesson on Monday, you should be able to do the following three things. So just so that we remember, groundwater is pretty intuitive because of its name, but it is the water located beneath the Earth's surface in soil pore spaces and in the fractures of rock formations. So we learned a while ago that 2.5% of the water on Earth is fresh water. Of that 2.5%, 30% of the fresh water on Earth is groundwater. So if we multiply 2.5% in decimal form by the 30% in decimal form, we get 0.75% of the water on Earth is groundwater. So that is not a lot of water at all. But it is important for our drinking purposes. So the water table is just the level in the ground where the soil stops being saturated. So it's the level of the saturated soil in the ground, level of the groundwater. We already know the definition of groundwater. So saturation means that all of the spaces between the sediment particles is filled with water, and that there's no more room for any extra water. And we know infiltration is when water goes from the surface of the earth down into the ground. Okay, so infiltration depends on several things. So precipitation, obviously, the more precipitation you have, the more water that's coming in, the more that is available to soak into the soil. The less precipitation you have, the smaller amount of water is available to soak into the soil. Soil characteristics like pore space that we'll talk about in just a minute. Soil saturation, so how much water content the soil already has. The land cover or the vegetation, because if you remember, we talked about things that influence the amount of surface water volume. So if we have land covers that are not permeable, so if we have things like parking lots or really hard clays or bedrock, the water can't soak into that. It's just going to run right off. But if we have areas that are covered in vegetation and sandy soils, then the water is going to very easily be able to soak in, and infiltration is going to increase. And then we have slope. So we talked about already that if we have really steep slopes, runoff is going to increase. And so there's not going to be as much water available for infiltration. If the slope is low, so if we have flat land like in the coastal plain, the water is going to be able to sit on the surface of the earth longer and soak into the soil. And then also evapotranspiration, so the amount of water that goes back up into the atmosphere through evaporation or transpiration. Okay, so pore space is just the amount of space between all of the sediment particles. So big sediment particles like gravel and pebbles and cobble, they don't fit together as tightly, and so they have pretty big pore spaces. So they have a lot of space in between each sediment grain to store water. And then you have teeny tiny sediment sizes which fit together better, so their pore spaces are smaller, but there's a lot more of them. So this influences the amount of groundwater and also the rate of infiltration. So if we have larger particles like pebbles and gravel, they have larger pore spaces. So there's more space to hold water. However, because of the cohesive properties of water, that space will drain pretty quickly. It's pretty easy to pull water out of that. But smaller particles like clays and silts, they have much smaller pore spaces, but there's a lot more of them. So overall, they have less space to hold water, but they fill really quickly because of capillary action, and they drain really slowly. They hold on to their water really tightly. So it's hard for us to pull groundwater out of clays. Okay. So we said the water table is the level of saturation in the soil, and that's influenced by several things. So the first thing is groundwater flow. So the water in the pore space of the soil under the ground moves from place to place. It moves from high pressure to low pressure, not necessarily always uphill to downhill. It's also determined by precipitation and infiltration. So the more precipitation we have, the more likely we are to have water infiltrate down into the soil. And then we talked about the things that influence infiltration. So but if we have high levels of infiltration, then we're going to increase water table levels. If we have lower levels of infiltration, then we're not going to be able to increase water table levels as much. Also, connection with surface water. So if water from a stream can flow down into the groundwater, that will increase the water table level. Or if we have water flowing from the groundwater into a stream, so we have a gaining stream, that will also lower the water table level. And then humans can put in things like pumps and wells to withdraw water from the groundwater. And so that pretty intuitively lowers the groundwater table. All right, so that is just about all I have to share with you today on groundwater and infiltration and water tables. We'll explore this topic a little bit more later.